For most children, it is the first vehicle they ever ride without a parent sitting beside them. In the United States alone, school buses carry 26 million children every day. That is more than all other forms of public and private transport combined. Because the bus is so common, we tend to view its design as a collection of traditions. We see the iconic yellow paint and assume it's a charming aesthetic choice or a simple branding requirement. In reality, it is one of the most regulated and statistically safest vehicles on any road. Every visible decision on this vehicle was made by someone asking, what happens when something goes wrong? Engineering the answer before the question became necessary. In 1939, engineers gathered to solve a specific problem: how to keep vulnerable pedestrians safe while they moved around large, heavy machinery. They identified a recurring environmental threat. Children move between home and school during dawn and dusk, the exact hours when low light makes it hardest for drivers to see them. The solution was the creation of a very specific color, now known as school bus yellow. This specific wavelength of yellow is detected by our peripheral vision faster than any other color. This forces surrounding drivers to register the bus out of the corner of their eye before they consciously look toward it. The paint isn't there for the children. It is a functional tool designed to exploit human neurobiology to force driver awareness. This philosophy of anticipating failure dictates the physical structure of the entire vehicle. Consider the problem of scale. A massive vehicle surrounded by small, erratic pedestrians creates several deadly blind spots. The engineering solution was to make the body of the bus sit high off the ground. That height allows drivers in surrounding cars to see the legs of children moving around the vehicle's immediate footprint, effectively eliminating the visual obstruction. Inside the bus, engineers had to account for a different threat: the impact of a collision. Active restraints like seatbelts are only effective if they are worn correctly, which is difficult to ensure with a rotating population of children. Instead, they use a principle called compartmentalization. The seats are designed as closely spaced, padded barriers that catch and cushion a passenger's momentum, using the seat in front as a restraint system. From the specific paint to the spacing of the seats, every detail is a pre-engineered response to a worst-case scenario. Because of this constant management of risk, the school bus has become the most regulated vehicle on the road. The children riding inside rarely know any of this. And because the yellow paint handles the job of alerting our peripheral vision, the rest of the public doesn't have to actively think about the bus's safety either. The school bus achieves its mission precisely because the engineering behind it is so effective, it has become invisible. It does all the worrying for us.